Today we will be working on the Unit 4B review, as you can see up here at the top. There are 3 sections to this unit, so we have already completed Unit 4A, and now we are working on Unit 4B. I will say that a lot of Unit 4A and Unit 4B build off of each other, so it may be a helpful idea, especially if you have been struggling significantly or you're maybe a little concerned about the tests coming up, that it would be helpful to go back and watch the Unit 4A review video. If you still have that packet, you could even follow along in that packet, but there are topics of Unit 4B that overlap with Unit 4A. So making sure that if you're kind of missing that foundation, to go back and watch Unit 4A if you have to. So in the first 2 questions, they're very similar. Basically what they're asking you to do is to do a table, figuring out these 4 points, same thing down here, figuring out those 4 points, and then using those 4 points to graph and then make a straight line. Now, some of you guys in class are really good at the whole y equals mx plus b, and you're like, hey, I know what the slope is, and I know what the b is, and you're like, I can look at this and say, okay, here's my b, this is my b value, here's my m value. So my b tells me that I need to be starting at the y-intercept of 0, -5, and then my slope would be, for many of you, 3/1. So you just go to -5, you'd count up 3/1 and kind of make your line that way. In this particular problem, they are in fact asking you to do a table. So if you were to graph that and put a dot at -5, go up 3/1, put a dot and make your line would be correct. Your graph would be fine, but I would still take off points because you did not fill in the table. And when there is a table, you're expected to fill it in. Now, the difference between these 2 tables are this first table, you can pretty much pick any number that you want over here. So a lot of people go like just 1, 2, 3, 4. Some people go, I've seen -2, 0, 2, 4. There doesn't have to be a rhyme or a reason to it. It doesn't have to be in order. You could go 4, 1, 3, 2. It doesn't matter the order. As long as you pick 4 numbers, sometimes it's 3, but in this case it's 4 numbers, any 4 numbers that you want. As far as the showing the work goes, I kind of border there. If you're constantly calculating them wrong, I would definitely say show your work. In class, the way that we showed our work was we would write the equation with a blank like this. So I would have 3 blank -5, 3 blank -5, 3 blank -5, and then you take your numbers here and you'd plug them in. So you'd have 1, 2, 3, and 4. Then as far as solving for y goes, you would just have to calculate each of these. So 3 times 1 gives me 3 minus 5. You don't actually have to show this. Some of you might just do this in your head. But I would have 3 minus 5 gives me -2. Down here, this would be 6. Then 6 minus 5 gives me 1. 3 times 3 gives me 9. 9 minus 5 gives me 4. This one would be 12. 12 minus 5 gives me 7. So I kind of get my values here. Now this last column is the part that I kind of want to spend a second or two because there was a lot of misconceptions during class or people that were just simply filling this in wrong, but then the graphs were fine. This one's actually kind of just asking you to bring the information together. You've got a 1 and a -2. Just bring them together. 1, -2. The next one, this would be 2, 1. Just bring your 2 numbers, the one that you started with and the one that you ended with as your 2 points. 4, 7. These 4 points are the ones that I then expect you to graph. So again, if you kind of went off of this method here, that's fine. Your graph would still technically be right, but you would have missed the table. But the table is kind of what I was looking for here. That would be 1, -2. I'd be at 2, 1. Let's see, I have 3, 4, and I would be at 4, 7. If you had plugged in the original ones, or this method here, you would have been at 0, -5. The up 3/1 would have put you right here. So again, kind of picking up with where your dots are already. And then you'd keep going up 3/1, up 3/1, and please do not forget to connect the dots. So a lot of you guys just did the dots, and you're like, yeah, I know to connect them, I know to connect them. But make sure you don't forget about that on the test. Number 2, I won't go through it entirely, but I will remind you that there are 2 words, domain and range. Domain is always talking about your x's. Range is always talking about your y's. So since they're talking about domain, what they're basically saying is, hey, I'm giving you the x's. Instead of you picking out some like we did up here, I'm actually giving them to you. I'm saying I'm taking away the option of choice and just saying, here are the numbers I want you to calculate. You would then come up here and plug in negative blank plus 3, negative blank plus 3, negative blank plus 3, negative blank plus 3. And then, of course, just going in, filling in negative 1, 0, 1, 2. Be careful because this will become a negative negative, which means this is coming out as positive 1 plus 3, which will give me 4. Negative 0 is really nothing, so I'm just 0 plus 3 is 3. Over here, this would become negative 1 plus 3, which gives me 2. Then negative 2 plus 3 gives me 1. And then, of course, you'd kind of continue what you did over here with filling in your points, taking these informations and adding them over here, and then graphing them, of course. The next one's still kind of going with this table idea, except this time instead of like a full equation, they're just giving you y equals negative 5. So that means you definitely need to plug in y equals negative 5. Or in this case, x is 4, so you definitely need to plug in 4. But as far as the other column goes, you can pick any numbers that you want, maybe 0, 1, 2. I would keep them reasonable. Like if you pick 50, 60, and 70, that's a little bit too big, so I wouldn't go those big of numbers. But if you wanted to do something, even 5, 6, and 7, that's fine. It might go off your graph a little bit, but you could use your imagination. So for example, I'm at 4, 1, 2, 3, 4. That's my x value, so I'm looking at x. I go to x is 4, and then my y is 5, so I'm going to go 1, 2, 3, 4, 5. My next one, I would be at 4, 6, and then 4, 7. So yeah, it's kind of going off my graph, but I can still at least see that the line's going to be something like this. And you can pick negative numbers too. I could have picked, over here, negative 1, negative 2. That's fine. So I'm at x is 0, and then my y is negative 5, 1, 2, 3, 4, 5. The next one, I'm at x negative 1, y negative 5. The next one, x negative 2, y negative 5. And you'll see that kind of line for me. Now I will say, using this as an example, this is a horrible line, and I'm not going to say that I'm going to take off points for a horrible line like that, but do try to make it as straight as possible, or if you want to use a ruler, even better. If your line goes like, woo, like something like that, I definitely would not accept that. But making sure you're clearly attempting to go through the 3 points that you were given, or even up here, attempting to go through all the points you were given, or use a ruler. When in doubt, just, use a ruler. Going on to the next page, solving for y has actually been the hardest topic for many people because a lot of times A1, you might recognize that you need to get rid of this 4x, but you're not quite sure how to send it over to the other side. You have this negative y, and you're like, I don't really know how to go about this. In this particular problem, there is 2 ways to go about this. The first one would actually be to get rid of the y, which is a surprise for most people, but since it is a minus y, for some people, it's much clearer to see, hey, let's add y, in which case over here the y's cancel out, leaving you with 4x. And on the other side, you have this 8 plus y. Now at this point, all you would really have to do is get rid of the 8, because the y is fine, but the 8 is a problem. I usually say division's your last step, but division means that your y is finally on the side by itself. This y is not by itself yet. It technically has this 8. So we should always be thinking of addition and subtraction first. So in this case, I have a positive 8. So in order to get rid of it, I'm going to subtract 8 on both sides, giving me 4x minus 8 equals y. Another common mistake is some people think that you can combine the 4 and the 8. You cannot. If you remember way back in Unit 1, we did combining like terms. So let's say that I gave you a problem that was like 4x plus 2x plus 9, right? And I said, okay, let's underline our like terms. And we would say, okay, well, 4x and 2x are like terms. 9 is the only one of his kind. Well, we underline these 2 things because they are like terms, and I can take 4 plus 2 and get 6x. But the 9 got a different underline because he is different. He can't be combined with the 4x and the 2x. So kind of keep that in mind. Same rule applies over here, that this 4x and this 8 are in different worlds. They don't overlap. So in this case, just leave them separate. If you're really used to that whole y equals mx plus b, you can simply kind of look at this and say, I do have y equals mx plus b. It's just backwards. So I can rewrite this and say I have y equals, where's my x? My x is the 4x, so that's 4x minus 8. Now you're in that format. You see here's your b, so I could go to negative 8. My slope is a 4 over 1, so I'm going to go up 4, 1, 2, 3, 4 over 1. If you wanted to continue, 1, 2, 3, 4 over 1, however many you want until you have that line. And then, of course, you're going to connect those dots. So that's, again, one of the methods, bringing the y over. One of my students actually recently gave me this wonderful view on how they solve it. And they said frequently, we'll do it with the second problem. Frequently what they do is they identify the piece that they want to get rid of. They want to get rid of this 5x because, again, they're trying to get this y by itself. So instead of thinking of as, oh, adding or subtracting, what they simply do is they get rid of it. So they got rid of it. And to send it to the other side, they say, oh, well, it's always just the opposite. So instead of a negative 5x, I'm going to put it on the other side as a positive 5x. And then, of course, you still have the 70, so plus 70. You could rewrite this actually the other way if you wanted to leave it as 70, and then to send this to the other side, you're going to have positive 5x. It doesn't really matter order. They're the same thing. So you could have, in theory, looked at this problem up here and said, oh, well, this 4x is giving me the problem. So let me bring it to the other side. So I still have my negative y, and I still have my 8. But instead of a positive 4, I want a negative 4 because I'm moving it to the other side. Whereas we do the pipe and we say, if it's moving to the other side of the pipe, it needs to change signs. So originally it was a positive 4. To move it to the other side, I need to make it a negative 4. So maybe that will work for you as far as getting rid of the x goes, is just thinking of as, in order to send it to the other side of the pipe, so I'm taking it, it was originally on this side, and I'm moving it to this side, I need to change the sign. So if this is a negative, I need to make it a positive. So if that helps a little bit, good. And then the last step, of course, is always divide, divide, divide. So in this case, I'm dividing by negative 7. Up here, I did not have to divide really by anything because the y doesn't have a number in front of it. Now in this problem, it technically has a negative 1 in front of it. So I would have had to go through and divide everything by negative 1. So sometimes it will have a number, sometimes it won't. It's all just kind of a matter of the problem given. So in this case, I had a negative 7 out in front, so I have to divide, divide, divide. 70 divided by negative 7 would give you that negative 10. And then plus a 5 over negative 7. You could leave it as that if you wanted. 5 over negative 7x. Doesn't really make a difference if you want to make that a minus 5 over 7 or plus a negative. I will say that this is still your slope, and this is still your y-intercept. So when it comes to graphing, I'm going to start at negative 10. But my slope, be careful with that negative in there. That's saying that I'm going up 5, 1, 2, 3, 4, 5. But since it's a negative 7, that means I'm going backwards 7. So don't go forwards, go backwards. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And you'll actually know I actually do dots, but it's a pen, so I can't really help it. Just make sure it's very clear which two dots you're connecting, and you will be fine. The intercepts is the next section. Intercepts, anytime you see that word, you should think cover method. Right? And the cover method basically says this. If I take this problem, let's start by covering x. Okay, so I covered x. That's going to give me a negative 4y equals 8. Okay, well now let's solve for y. That means divide by 4, or sorry, negative 4, and that's going to give me negative 2. So my first answer that I got is y equals negative 2. Let's graph that. So I'm going to come over here, and I'm going to go to my y-axis, and I'm going to go to negative 2. Okay, done. I have 1 point. Awesome. Now let's figure out the second point. So this time, let's cover up the negative 4y. Well, that's going to leave me with a 2x equals 8. So I have 2x equals 8. Now I need to solve, so let's divide by 2. That gives me x equals 4. That's my second point. So let me go to the x-axis, and let me go to positive 4. 1, 2, 3, 4. Here's my second dot, and I am now done. So these ones aren't really meant to be long problems, as long as you realize that when I say intercept, what I'm saying is the cover-up method. Some of you may be thinking to yourself, well, I don't really understand the cover-up method, or I don't remember learning that. We also learned it as saying, let's say x equals 0, and then we would actually plug in 0. Well, negative 0 is just 0, so I'm left with y equals 4. So now I have this point that's technically 0, 4, and I would graph that. Then I would do it again, except this time y would be 0. So I'd come up here and I'd have negative x plus 0 equals 4, negative x equals 4, therefore x equals negative 4. And now I have the point of x, comma, y. And I would kind of graph these 2 points. So that would be 0, 4, and that would be negative 4, 0. And then I would have my line. So again, they're the exact same idea, except with the cover-up method, we're not actually saying, like, let's acknowledge the 0. We're pretty much just assuming the 0 is there, and it makes that term go away, because 0 always just makes the term go away. So either method is fine, whichever one you want to do. Down here, again, we reviewed this in class, so not spending too much time here. This is simply, for both of these, that y equals mx plus b, y equals mx plus b. A reminder that m is your slope, b is your y-intercept. So when I'm looking at this, I usually start with the y-intercept because it's the easiest, and I say, where does it intercept the y-axis? That's going to be, I'm going to leave a blank here for the m. So my b is 2, so I'm going to have plus 2. Then for your slope, you kind of count your rise over your run. But I will say, in this particular problem, it was a little tricky, because if you look really closely, they're going by intervals of 2. So when I'm looking at this, yes, my up and down is only 1. They're going at intervals of 1. But my run right here, it looks like it would be 1 because it's only one space on the grid. But it's actually going from 0 to 2, which means I move 2 spaces, which means my slope is my rise over my run. So again, just kind of be careful with that. I'll zoom in for a second. You can kind of see the 2 and the 4 a little bit better. Over here, these grids are not marked. So again, that would just be assuming that it's 1 by 1. So if you count your rise over your run, it's still just going to be 1 by 1. But just kind of keep that in mind. Let me flatten that back out. Oops. There we go. All right, moving on to the next page then. Sorry, don't worry about the background information. These top ones were the special line equations. So again, I mentioned this in class. If you see the word special lines, you should be instantly thinking that my answer is either going to be a y equals or x equals. They're not meant to be hard or long problems. It's very straightforward, boom, boom, boom. I will say that in your notes it says like the m equals b equals. More of just kind of a guideline, but you can do these problems a lot quicker. So when I'm looking at this first problem, I should notice something special going on, henceforth the name, special lines, right? I notice that this line is only crossing the y-axis. It will never actually touch the x-axis. Here's the x-axis. It's never going to touch the x-axis. So when it comes to the equation of my line, the only thing that I get is a y equals. Because if you think about it, we normally think of it like this, y equals mx plus b, in which case I have a y and an x. That's assuming that I'm crossing both the y and the x-axis. In this case, I'm not doing that. I'm only crossing the y-axis, so I only get a y. And in this case, y is negative 3, so I'm going to be at y equals negative 3. Same thing with number 12. This is a special line case because it's only crossing the x, so I only get an x. And in this case, x equals 2, and I'm done. So these don't really have to be that long, but do keep those in mind. The next one down below has this word undefined, so I'd like to take a second and go back and tell you guys what does undefined mean, or remind you guys should already know. When I'm looking at this first graph over here, I always say in class, think of it as a treadmill. This treadmill is perfectly flat, so my incline is currently at 0. I haven't started inclining or anything like that, so my slope is 0. So in any case, if I were to say like the same question here, and I said write an equation on a line with a 0 slope for the y-intercept of negative 21, you would have this equation. You would have y equals 21. But in this case, it's saying undefined. An undefined slope looks like this second one. This is so steep that even if I set my treadmill like this, I would not be able to walk on it. It's so steep that it is actually unclassifiable. It's undefined, right? So undefined lines will always be x equals. So if I know that this is going to be an x equals, and then it tells me that my x-intercept is 21, I know that my equation is simply going to be x equals 21. Number 14 is very similar to the front problems. Just think of this as your m, and this is your b, and then plug it in to your standard form over here. Number 15, this is a fun one. This is the one where it says, here's my slope. So define that as your m. Here's some random point. Let's call it x1, y1. Again, it's my first point, so I'm going to classify them both as 1s. And then kind of plug it in over here. So I'm going to have y minus y1 equals my m times x minus x1. So again, I just kind of plugged everything in. At this point, hopefully you'd look at this and say, OK, let's distribute, right? So when I distribute, kind of smaller in space, you guys should have a little bit more space. I should get that y minus 9 equals 1 over 5x minus, type this into your calculator if you don't know it, 1 over 5 times 5 should just give you 1. And then last but not least, you do have to get rid of this minus 9 by adding 9. Remember what specific piece that 9 is getting added to. You only get 1 on each side, so don't try to add 9 to 1 over 5. You're already adding 9 to 1, so you only get 1 plus 9 on each side. So over here, these guys cancel out, leaving me with just the y. The 1 over 5, I called it Medusa in class because it usually never changes. No matter what you try to do, it never changes unless you're like dividing, but you won't be dividing in these cases. So never change the x, Sol Medusa, it stays the same. And then that negative 1 plus 9 gives you 8. Number 17 and 18, 18's on another page for you. It's actually the exact same process as what we just did up here. The only difference is my m, I have no idea what m is, right? So I kind of have to use this m formula that they give me. And I'll call this, it's always x, y, x, y, for those of you that are still getting that confused, x, y, x, y. This is my first point. This is my second point. And then I just plug it in exactly. I have y2, which is 16, minus my y1, which is 10, over x2, which is 6, minus x1, which is 4. If I simplify that, I'm going to get 6 over 2, which is equivalent to 3. Again, this formula tells me m. So I now know that my m is 3. I can come over here and plug in my m. Do remember that you're going with your y1 and x1. So that's going to be 10 equals 3x minus 4. And then very similar to what you did up here, you're then going to distribute and ultimately bring this number over to the other side. So I'm going to distribute and get y minus 10 equals 3x minus 12. And then just like the 9 up top here where I added it, I'm going to add 10. And that's going to give me y equals 3x. Careful, negative 12 plus 10, negative 2. All right. So again, you have another example you can do by yourself. Same idea. Start with the m formula. Right. Start with that formula. Label these x, y, x, y. Make sure these are your 1s, these are your 2s. As far as 1s and 2s goes, it doesn't make a difference. I just think it's always easier to go 1, 2. And then last but not least, you have these word problems. We did these in class for the most part. But basically, both of these problems and most word problems that we will see in this unit will always be looking for this y equals mx plus b form. And always for y equals mx plus b, you only need to know 2 things. You need to know your m and your b. So again, m's usually your slope, or also known as your rate of change. And then your b is usually your starting point. So when I'm reading any of these problems, if it says that Tyler started with $50 when he began his job, but his new job pays $300 per week, I said per is that like cat sound, however you want to think of it. I forget the purr as in the cats can climb walls. I don't know. However you want to remember it. Or meow. I think, M, meow, cat, purr. Cats purr, cats meow. So this is going to be your M. however you want to remember it. I don't know. It's just one way. $50, since that's what he started with, is going to be my B. Same thing if I read this part. It says that right now, where is he starting at? He's starting at 410 pounds, so that's going to be my B. Then you'll hear that word per, meow, and think 2 pounds, so that will be my M. So when I set these up, all I'm really doing is y equals my M, x plus B. Or in the second one down here, I have my y equals my M, x plus B. The only thing I will caution you with this one is it clearly says losing. So like if I'm losing money or I'm losing weight or I'm losing anything, it's usually a form of subtraction. So this would actually be a -2. But he still started with 110 pounds, or 410 pounds, so it starts like that. Then as far as part B, that's usually just saying you're plugging something in. This one's saying I do not know how many weeks have gone by, so I don't really know the x. But I do know that my total amount, my total over here, is this 1250, so that's going to be my y. And then it's just a matter of being able to plug it in and solve for x. So that would mean subtracting 50. And some of you might even choose not to plug this in for y. You might just mentally think through it and say, okay, well, if he started with 50, I'm going to take away 50. That gives me $1,200. If he's getting $300 per week, let me just divide. And basically what you're doing is actually doing this equation, but all in your head. So when you're thinking divide by 300, that's actually what you do when you solve it. It's just some of you might just mentally think through this, and you get 4 equals x. Don't forget that anytime you're working with word problems, we should have labels in there. So they asked me how many weeks, so this is 4 weeks. And that'd be it. Same thing with the second word problem. They give you the total pounds. You just want to plug that in for y and solve for that then. That brings us to the end of the review packet. Again, the answer key is posted on Canvas, so check that out. If you have any further questions, see me, but the test is coming up very rapidly, so make sure that you study and ask questions. Do not ask questions on test day. By then, you either know it or you don't know it. But see me before the test if you need help, like the day before, maybe the day before after school. Stay after school, and I'll help you as best as I can. If you need, we can work on graphic organizers or something to help you out there. But please make sure you are studying for your test. Good luck.